Somebody asking me to go over chapter 10 review number 2 on the question 8, 9, 16, and 17. So let's start with question number 8 first. Find the area of a regular 24 gon with radius 7 millimeters. Okay, so you already got the formula for this problem. I gave you the hard copy. I also post the formula page on your locker. So let's go to your locker. Go to geometry, go to chapter 10, and here we go. Formula, area formula page. Alright, so make it bigger a little bit. Alright, so in this page, you have the area formula for square, rectangle, triangle, parallelogram, trapezoid, circle, square, rhombus, and kite. If you know two diagonals, you can use the same formula. And for regular and gon, you got 3 formula right here. If you only know, let's go back to the problem. They only give you the radius, okay? So you would use the last problem over here. If only know radii are, then you got this formula, okay? So let's click over here first, and then, oh, should be there. Leave it there for a second. Okay. So here's your formula. Here we go. Here we go. Let me make it nicer a little bit. Here we go. Okay. So area equal half nr square sine 360 over n. N is the number of sine. R is the radius of your regular and gon. In this formula, n appears in 2 places. N right here, and also n right here. Okay, let's see here. Here we go. So n over there, and n over here again. Alright, so let's clear that. So now I open decimal.com. No, I'm sorry, decimal calculator. So I type DESMOS calculator, and then I choose the second option over here. Then make it a little bit bigger so you can see it. So let's type the formula in half. Okay, and I would put multiply n, multiply capital F square, and then multiply with sine. So when you use sine, make sure it's in degree mode. In this calculator, by default, they already set up degree mode. Okay, degree mode right here. So you don't have to worry about that. So now I enter sine right here, 360 over n. That's it. So now you got your formula. Okay. Now go back to the problem over here. You know the n. They give you n 24 gon. So I go back to the calculator over here. I modify n for 24. And n over here also 24. Okay. And I need to modify the radius. Oh, let's see. Go back to the formula. Radius. I'm sorry. I enter capital S. It should be lowercase r for radius. So radius is 7, so I go over here, I revise it to 7, and voila, I got the answer. So look at the requirement for your answer. It's near 10, it means 1 decimal. So I would enter 152.2. Okay, so 152.2. Voila, I got it correct. And let's try one more time the same problem but do similar questions. So I can click similar. So now it changed to 30gon with radius 7. So I can go back to my decimal calculator. All I need to do is modify number 24 become 30. And then 24 here also become 30. The radius stay the same for 7. So I got my answer this time 152.8. 152.8. 152.8. So the advantage of using decimal calculator, you can go back and modify your formula over here and then come out with a new answer. Later on, you can see that you can copy the whole thing and paste again if you want to. All right, so we're done with question 8. And this question 8 also already posted, and I will show you how to find it on the solution I posted. Okay, so let's see here. Look at this number over here. Here we go. You see right there? 10.5.11. But you need to pay attention to the first two numbers, 10.5. It means this question already appear in the solution of 10.5. So let's go and find that question, that solution. Go back to the locker. 10.5 right here. 10.5. Solution of 10.5. So you click that. And then let's go and find that question. Voila, number 5 right here. Very similar on the problem number 8 on chapter 5 review number 2. 30gon with radius 12 millimeter. So I write the formula right here. A equal half n r square sine 360 over n. And again, I substitute 30 for n, 30 for n. See that? 30 for n. And then 30 for n over here. Okay. And then the radius, I substitute for 12. For 12. Here we go. Now we move on to question number 9. Number 9. Okay. Number 9. Find the perimeter and area of the regular polygon. And they give you the diagram of a regular octagon A size. Okay. They give you the radius 13 meter. So the first question, you need to find perimeter of regular polygon. So again, this question, I already posted the solution. Over here, 10.5. So we go to 10.5 solution. Okay. Here we go. Voila. It's very similar to question number 11 over here. Okay. So if you need to find the perimeter, here we go, perimeter. Perimeter, you add all the sides of your polygon, or you can multiply the number of sides. So in this case, the octagon have 8 sides and multiply with the measure of one side. So you use this formula, perimeter equal n times s. So we need to find s because the n we already know, octagon, so n equal 8. Look at this octagon over here. The angle over here created, formed by one radius and one arbitum. This angle is always 22.5 degrees. Okay, let's find out why. Here we go. So this is the octagon. So when you connect the opposite vertices together, okay, they meet up at the center of your octagon, and you have 8 angles created by 2 radii next to each other, and 360 you divide by 8, so the angle would be 45 degrees. But the angle created by the radius and one arbitum is only half of the angle of 45 degrees. Okay, it's right here. So that's why it's 45 degrees. You divide by 2, so you got 22.5. So go back over here. In this right triangle, you set up sine 22.5 degrees equal opposite over hypotenuse. Opposite, which is this value right here, which is happen to be sine, you divide by 2 because you don't have the whole side, you have only half. So that's the opposite over hypotenuse. Hypotenuse happen to be the radius. So I put over here opposite as over 2. So that's opposite. And then hypotenuse happen to be 13. Okay. So now first I solve for s over 2. So s over 2, I cross multiply 13 to the front of sine 22.5 degrees. And now I don't want the number 2 here, so I can cross multiply the 2 up here. Okay. So now I got sine equal 2 times 13 times sine 22.5. Alright? So now I substitute the value of sine 2 times 13 times sine times 23.5 into my formula over here. Okay. So 2 times 13 times sine 25 degrees right here. Here we go. And all I need is to punch in the calculator. So I got 79.6. Okay. So let's do that calculator on decimal let's do that calculation. From over here, I just press enter. So I come to new line. Okay. So 8 times 2 times 13 times sine, I can click on the side over here, 22.5. And I got my answer, 79 point, let's see the requirement. They said near 10, so 1 decimal, so the answer only 79.6. Okay. So now go to back to the problem over here. Oh, they also give you 13. Perfect. So the answer is exactly the same. So would be 79.6. All right. So we find the answer for the perimeter. Now the next question is find the area of the regular polygon. Okay. So in this, you know, the octagon, you only know the radius. So I can go back and use the formula, the previous formula. We don't use it. This formula right here. Here we go. You see that? But all I need to do is modify the number of sides, which is not 30 anymore, octagon, which is 8. So let's go and change it to 8. And then go here, change to 8. Okay. And the radius is 13 now, so I go to 7 over here, I change to 13. Now I got my answer, 478. Look at the requirement, near it 10 to 1 decimal. So the answer 478. 478. 478, that's it. Voila. Okay. So let's do similar again. So go back to this formula on the calculator over here. The radius now changed to 7. So instead of number 13, I change to 7. Okay. And my answer with 1 decimal should be 42.9. 42.9. Okay. And the next question, I want to find the regular of my polygon. I already know the radius, which is 7. So I go to this formula, the previous formula over here. Octagon, so the number of sides 8, 8 stay the same, but 13 now it changed to 7. Voila, I got my answer. 138.6, 1 decimal. So 59 becomes 6. So 138.6. Okay, done. So we're done with question number 9. Let's move on to question 16. 16. So you got the diagram. You need to find the area of the shaded sector of the circle. So you need to know the measure of the arc of this sector from here to here. That's half of the circle. Okay, and this one is 120 degrees. So the leftover for this angle right here of the sector has to be 60 degrees. So let's find the formula. First of all, let's find out the solution of this problem. It lists this under section 10-7. Okay, so let's go over there. Go back to my locker and click on 10-7. Oh, right here on the top. There we go. 10-7. Voila. Let's see which one. All right. It looked very similar to problem number 9 and number 10 over here. Very similar. Okay. So you need to find the area, the measure of your sector. In this case, 50. So the formula is area equal the measure of the arc of the sector divided by 360 multiply with pi r square. Okay. So I go to my decimal calculator. Let's type it in. Let's type m over 360. M is the measure of the arc of the sector. Multiply with pi. Okay, I have pi button right here. Okay. And then multiply with what does it have to multiply with? R square. So R square. All right. So I find out the measure of the arc of this sector is 60 degrees. So let's change it to 60 degrees. Oops, 60 degrees over. Oh, let's go back here. 60 over. Let's times 360. Then delete the 360. All right. And the R happen to be, look at it, give it to you is the diameter 16, but you want only the radius, which is only 8. Okay. But the answer over here is a decimal number. Go back over here for the question. They said they want the answer in terms of pi. Okay. So I go to the formula. I just take out the pi for now. Oh. So I guess I have to simplify. Okay. So simplify. So let's simplify it. 360, 60, and go over here. 60 you simplify with 360, so that would be 1. Come on. 1 over 6. Okay. Pi, we leave it because we want the answer in terms of pi. 8 square, which happen to be 64. Oop. 64. All right. So I simplify 64. I simplify by 2. That becomes 32. And then 6 simplified by 3. So my answer is 32 over 3. And of course it comes with pi. So let's type it here. 32 over 3 and pi. Okay. So that's our answer. All right, we're done with number 16. Now let's move on to number 17. Okay. And number 17, you can see it belongs to the solution. Number 17 belongs to section 10-7. Okay. So let's go and find under 10.7. All right. It look, let's double check up here. I think it looked very similar to problem 21 and 22 over here. Okay. So you want to find the area of shaded segment over here. It should be equal the area of the whole sector, and then you subtract the area of the triangle. Okay. So over here, area of sector, you take the arc of the measure of the arc of the sector, which is 65 degrees. Okay. Divide by 360, multiply with pi r square, and then you subtract with the area of the triangle. This triangle, we don't use the formula base times height divided by 2. We use the formula half the two sides here. This is 8. This one should be also 8. This one also A. Okay. So half times A times sine 65 degrees. So when you punch it your calculator, make sure the answer near 10. So let's do that with the problem 17 over here. Okay. Let's go to the next line over here. So let's enter m over 360 multiply with pi r square. Okay. And then you subtract with the area triangle is 1/2 multiply with the sine and the sine and the sine of the angle between the two sides. Okay. Alright. So now let's substitute the value in. Substitute the value in over here. Oh, let's go back. Get rid of that. Alright, I got it a little bit. Okay. Let's see over here. Let's hide it for a second. So in this problem, the measure of the arc is 75 degrees. So go over here, I change to 75. 75. 360. I change to 360. Alright, pi r square. R happen to be only 5. Alright. Subtract half sine times sine. The two side happen to be 5, which is the radius. Okay. And then the angle right here also happen to be 75 degrees. So I put 75 degrees there. That's it. And I got my answer. Nearer 10, 1 decimal. So the answer should be 4.3. Okay. So since I have decimal calculator, I can do a similar question, and I just revise my my values into the formula. So I click similar. Now we got a diagram very similar to the previous one, but the number different. The measure of the arc of the sector is now 80 degrees. So let's go over here and change to 80 degrees. The radius happen to be 6, so I change to 6. Subtract half, sine times sine. It's not 5 anymore, it's 6 now. So I go and change to 6. And then sine of 80 degrees. So the answer with 1 decimal, 7.4. 7.4. That's it. Thank you for your attention.